Good morning, class. Let us start with the next chapter, that is the last chapter of your math syllabus. That is chapter 15, Visualizing Solid Shapes. Visualizing solid shapes. Okay, before starting with the chapter, let us understand the heading first, the topic first. Visualizing. What do you mean by visualize? To see, yeah, to observe, to see, to observe, yeah, to perceive something, to perceive something. That is what it makes. That is what it makes. What? The visualizing solid shapes. Clear with this? So basically, when we discuss about visualizing, we see, we observe, we perceive these shapes. Okay. Now, see, how do we see anything? How do we see anything? We see anything with the organs provided by God to us, that is eyes. Yeah, that is why two eyes have been provided, so that we can have wider view. We can see right and left through eyes. That is why the two eyes have been provided. And hence we can see and we can visualize. Visualize means to see completely. That's what makes visualizing, to see, to observe, to perceive the solid shapes. Okay. Let us understand what do you mean by solid shapes. Okay, shapes. And after shapes we have added an adjective, solid. What it means? Basically, what it means, solid means heavy. Is it so? No. Understand, solid shapes means 3D shapes. When we talk about 3D shapes, it means that solid shapes. What do you mean by 3D shape? 3D means three-dimensional shapes. Three-dimensional shapes. Now, you might be thinking, what are dimensions? Dimensions are those parameters by which we can construct or we can build any shape, any object. That is what dimensions means. It means three-dimensional shape means we require 3 dimensions. What are those dimensions? If we talk about those dimensions, means length, breadth, height, radius, base. Now, you might be thinking, sir is talking about 3 dimensions, but he has written 5 things. Yeah, 3 dimension basically here means we'll be taking out of this 5 3 dimensions at a time. 3 dimensions at a time. That's what it makes 3 dimensions. For example, I may consider length, breadth and height. I may consider radius only. 3 times I may consider radius. Maybe I am taking base, breadth and height. I can take any of the combinations, but I have to take 3 dimensions at a time, and hence it is known as 3D or solid shape. So in this chapter, we will visualize these solid shapes, and visualizing here means to observe, to see. For example, I see something. For example, I see this object. What I'm doing? Not only seeing, but I have to observe that how this particular thing is made, what parameters are used, what I can do with this, what are the examples of this. So that is what visualizing here means. Clear? So 3D shapes. It means we'll be focusing more on the 3D shapes in this chapter. Clear? Now, let's see the difference between 3D and 2D shapes. That's very important. Let's see the difference between 3D and 2D shapes. 2D and 3D shapes. Let's see the difference. First important difference, what is that? Yes, they need 2 dimensions. Very important. Now the dimensions are, it can be length, it can be breadth, it can be height, it can be base, it can be radius, provided will be taking 2 dimensions at a time. That's very important. Clear? Now, for 2D shapes, what we can find? For 2D shapes, we can find parameter and area. We can find parameter and area for 2D shapes. Next, example of 2D shapes are rectangles. Brilliant examples. The class of quadrilaterals, triangles, square, rhombus, circle, etc. are the examples of 2D shapes. Next, they are known as plane figures. They are known as plane figures. Very, very important point. Why? Because it looks like a plane, the surfaces look like a plane, hence we call them as a plane figures. Are we clear? Next, 3D shapes. First point regarding the 3D shapes, 3-dimensional. They are 3-dimensional. They need 3 dimensions. Those dimensions are length, breadth, height, base, radius, etc. But 3 dimensions at a time. 3 dimensions at a time. Next, we can find parameter, area and volume for this. We can find parameter, area and volume for this. Clear with this? We can find parameter, area and volume for this. Next examples, we'll be starting with this cuboid, cube, cylinder, cone, sphere, hemisphere, prism, pyramids are the examples, etc. are the examples of 3D shapes. They are known as solid shapes. 3D shapes are known as solid shapes. Are we clear with the differences? These are the important differences between 2D and 3D shapes. Very, very important. You must know 2D and 3D shapes. Are we clear? Now, let's observe one thing. If I talk about chapati that you eat, chapati is the brilliant example of sphere. It's 3D in shape. Don't think it's circular. Though it looks like a circle, but it is 3D because it is from both sides. There is that dough you make. That's a 3D. That's a 3D part. So do remember. I'll take an example of cuboid. Cuboid. It's a cuboid. It's a cube. It's a cube. It's a cone. It's a cone. We'll discuss all the factors. It's a cylinder. It's a cylinder. Sphere. Have you seen the balls? Have you seen the football? They are the best example of sphere. Now, let's see the example of prism. This is the best example of prism. This is called prism. We'll discuss what are prisms. This is the best example of pyramid. Egypt, you would have seen pyramids. This is the best example of pyramid. Are we clear? Any doubt anyone is having with this concept? Now, why we are calling them as solid? Now the thing is that, okay, shapes we understand, 3D we understand, but why we are calling as solid? In science, you would have studied the states of matter. The states of matter basically solid, matter, solid, liquid and gas. Are we clear? Solid, liquid and gas. Now, solid, when we talk about solids, they have fixed shape and volume. That is the most important thing. Yeah. Next important thing that we consider, they have very less intermolecular spaces. Very less intermolecular spaces. It means, can I say, they are tightly packed. They are tightly packed. From this, what we confirm? That when we are talking about solids, it means they have fixed shape, we cannot. We have to use the force to change their shape. Secondly, when we talk about the solids, they have fixed volume. Now, what do you mean by the volume? Volume basically means the space occupied. And yes, they occupy too much space. Hence, the volume of solid is much greater as compared to the other states of matter. These are two important. Hence, we are including solid shapes. Means these shapes will be having a fixed shape. Cuboid is cuboid, cube is cube, cylinder is cylinder, cone is cone. We cannot. If I modify this, the shape will be changing. It will not remain cone. It will change to something else if I modify. For example, if I modify it, it will change into pyramid. The names are different. If I change a cylinder into prism, the names are different. It is cylinder, it is prism. This is what I am talking about. That is why they have fixed shape and volume. And every one is having their own volume. Are we clear with the concept with this? Okay. Now, let us study the few parameters by which the things are made. Let's see. To obtain a solid shape, we need three basic parameters. What are those parameters? First parameter is phase, second edge, third vortex. Understand? Phase, edge and vortex. Let's see. Let's study about the phase, vortex and the concept. Let's study about this. Any flat surface is known as phase. 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 So what is phase? A flat surface. Best example, this is one of the phase. It's a flat, a plane surface is known as what? A face. So if I talk about cuboid, how many faces are there? Cuboid is having 6 faces, for example. 6 faces. Edge. What do you mean by edge? Edge basically means line segment, right? A line. For example, this is the edge. Now what do you consider from this? Can I say edge a line where two faces meet? Yes or no? This is what I can say. Edge or a line where two faces meeting. So this is an edge where two faces are meeting. So what is edge? A line where two faces meet. Next, vortex. This is vortex. This is vortex. This is vortex. This is vortex. Can I say vortex? The another name of vortex is corner. Now understand, what is vortex? A fixed point where two or more edges meet. This is what vortex is. This is the vortex. How many edges are meeting? 1, 2 and 3. That is why I am saying 2 or more edges meet. That makes it as corner or a vortex. So these 3 parameters are very, very important to make any solid shape in the nature. Maybe one is there, 2 are missing. Maybe all the 3 are there, maybe 2 are there. But these are the fundamental parameters that we need to have any solid shape. Are we clear? Now let us start one by one with the parameters, with these shapes now. Let us study first cube and cuboid. Let us study first cube and cuboid. Cuboid, cube. What do you mean by cuboid? Basically, when I talk about cuboid, a 3D shape figure having rectangular faces. Understand. A 3D figure having 6 rectangular faces. Let's observe. Let's observe the cuboid. Let's observe the cuboid. 1, 2, 3, 4. This is a perfect example of cuboid. Yes or no? This is a perfect example of cuboid. Why I am saying 6 rectangular faces? Because when I talk about cuboid, do remember, whenever I talk about cuboid has 6 rectangular faces. I'll prove, don't worry. I'll prove in front of you that why we conclude that it has 6 rectangular faces. Are we clear? Now let's observe the vertices then. Let's observe the vertices. How many vertices are there? That we need to see. 1, 2, 3, 4, 5, 6, 7, 8. How many vertices are there? 8 vertices are there. How many edges are there? Edges we have to see. Edges means line segment. Let's observe the line segment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many edges are there? 12 edges are there. Can we see clearly? This room where you are sitting right now, if you are sitting in a room, you can observe that room is a perfect example of cuboid. You can see top faces. If I talk top, bottom, right, left, front, back, 6 faces. Points 1, 2, 3, 4, 5, 6, 7, 8. Edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Are we clear? Now, how to write cuboid in the form of cube? What is cube basically? If you observe both this is cuboid, this is cube. What is the difference? Don't you think they look identical in some aspect? That aspect, only the difference is here the faces are rectangular in shape, but here the faces are square in shape. Now, if I talk about cuboid, so we are having 3 dimensions. Those dimensions are length, breadth, and height. Yes or no? Because it's a 3D shape, we need the 3 dimensions. Those 3 dimensions are length, breadth, and height. If I make this length, breadth, and height equal, what is square? If I'm saying cube is having square faces, how will you get the square? What is square? A special type of rectangle whose length is equal to breadth. Simple. Length and breadth are equal. So if we want to convert a cuboid into cube, what we have to do? Just make length, breadth, and height equal and you'll be getting cube. That's what we'll be going to do. So if I have to draw a cube, what I'll do? I'll convert length and breadth equal and then I'll draw and I'll get a cube. A perfect example of cube. Yes or no? It's a cube. It's a cube. Why? Because the length, breadth, and height. Length, breadth, and height are equal. It means that a 3D shape having 6 square faces. Any doubt? Square shape faces are there in cube. Let's see. First, second, third, fourth, fifth, sixth. 6 faces. Edges, of course, edges will be equal to cube. Cuboid only, no? It will remain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 edges are there. How many vertices are there? Vertices, if I talk about 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. They are identical in shape. The best example of cube, your dice cube. ice cube, etc. are the examples of cube. Cuboid, any shape, room, symmetric box, matchbox, all are examples of cuboid. Are we clear? Are we clear with two shapes, cube and cuboid? Let's move on to the next two shapes, that is cylinder and cone. That is cylinder and cone. Let's move on to the next important shapes. Cylinder and cone. Yeah, understand. This is cylinder and this is cone. This is cylinder and this is cone. What we got? A hut. Yeah, we got a hut, right? Let's observe what I'm trying to conclude from this. Cylinder basically this is a cylinder, this is a cone. Clear? Now how somebody will define a cylinder? A 3D shape for sure, no problem. A 3D shape, a 3D figure having two flat faces and one curved face. This is how we define. Now understand why two flat surfaces. What do you mean by face? Flat surface. Flat surface. Flat. But this is curved, but it is flat. It is flat but curved. So hence cylinder is having two flat surfaces and one curved faces. So that's why figure is having three faces in total. Next, let's discuss about vertices. Vertices means corner. Do you see any corner in a cylinder? Anywhere? No corner. That is why zero vertices. What do you mean by edges? What do you mean by edges? What do you mean by edges? Edges basically means the line segment where two faces meet. For example, if I open this cylinder, what I'll get? I'll get this picture, the front part and two circular part. Yes or no? And two circular part. Hence, how many edges are there? I can observe there are two edges. This edge, because here two faces are meeting. This edge, because here two faces are meeting. Therefore, two edges are there. Are we clear? Next, let's move on to the cone now. Cone, a 3D figure having one flat surface and one curved surface. Yeah, you can see clearly flat surface and one curved surface, plane. So having one flat surface and curved surface. So how many faces are there in a cone? Two faces are there. 1 plus 1, 2. Now let's observe the vertex. Yes, we have one corner. We have one corner, that is why vertex is 1. Let's observe the edge. Now if I open the cone, it will look like this. A flat. The curved part will change into a rectangle. If I open, and this circle will remain as it is, as a circle, like this. Hence, can I say that a cone is having one edge where two faces are meeting? Yes, it has one edge. Example of cylinder, the gas cylinder, pipes, etc. Unsharpened calcium is also example of cylinder. Cone, birthday cap, ice cream is an example, brilliant example, etc. are examples of cone. Next, let's do the next two shapes. Before that, let's see the sphere. How does sphere look like? Sphere is like a ball. So sphere is having if I talk about faces, if I talk about vertices, if I talk about edges, face only one curved face, 0 vertices, 0 edge in a sphere. You can see a ball. There is no line, there is no corner in a ball. Are we clear? Next is last important topic, that is prism and pyramid. Let's see what is prism first. Observe this figure. This figure is called prism. Yes or no? Prism. Yes or no? Prism. What do you identify? The front and the back face are identical and rest of the faces are identical. Yes or no? If you observe clearly, what do you observe? The front and back are same and rest of the faces are identical. So, can I say, how I will define this? I will define it as a 3D figure. First thing, most important. Secondly, having two faces as polygon. That polygon can be anything, and rest of the faces are in which shape? Parallelogram in shape. This is what is happening. If I talk about prism, polygon, but rest of the faces are parallelogram. This is what is the best example. Hence, if I put prism like this, what is the base? Base is parallelogram in shape. So, a 3D figure whose base is parallelogram in shape, but two faces are polygons, that figure is known as prism. That figure is known as prism. Are we clear? Now, based on the polygons, we name them. If your polygon is triangle, we call it as triangular prism. I'll show you. This is an example of triangular prism. This is triangle because triangle polygon, triangular prism. Observe this. 1, 2, 3, 4, 5. Pentagon, pentagonal prism. Pentagonal prism. 1, 2, 3, 4, 5, 6. Hexagonal prism. So we name the prism on the basis of polygon. Are we clear? On the basis of polygon, we'll be naming that particular prism. Clear? Again, this is also a pentagonal prism. Clear with this? Now let's move on to pyramid. Observe the pyramid now clearly. Observe the pyramid. What do you observe? The base is in some other shape, a polygon, but the rest of the faces are triangular in shape. Yes, this is what a pyramid is. A 3D figure having base as a polygon. That polygon can be any, but rest of the faces are triangles. Are we clear? So if the base, let me take an example. For example, this is called square pyramid. This is called square pyramid because base is square in shape, square pyramid. Square pyramid. This is hexagonal pyramid. Hexagonal pyramid. Pentagonal pyramid. Pentagonal pyramid because base is pentagon in shape, pentagonal pyramid. Triangular pyramid, the smallest one. Triangular pyramid. Triangular pyramid is the smallest one. How do we draw? Just observe. One triangle. Inside that, another triangle. Join this. This is an example of triangular pyramid. Next, here, just observe. Prism. How to draw prism? Just draw a rectangle. Of that, another. Just draw a parallelogram, or rectangle, whatever. Inside that, another triangle, and join this. This is a perfect example of prism. This is known as triangular prism. This is known as triangular pyramid. By this, the solid shapes are over. Let's move on to the next topic, that is netting. Now, what do you think? It's easy to observe 3D figures? No. For example, the trend was there to watch 3D movies. But for those 3D movies, once you reach the theater or the cinema hall, you require something special. What is that something special? That 3D glasses. What that makes 3D glasses special? Because at one particular time, two planes are moving together. So three planes come together and that looks like natural, that looks like original. But our eyes can visualize only 2D figures. Whatever we are seeing only 2D part. The third axis we are not able to see. 3D basically means 3 axes, no? If I talk about 3D means 3 axes, Y, X and Z. This third one is the another axis called Z axis. So we are not able to see this axis, we are able to see these 2 axes, Y and X axis. Are we clear? Hence, this makes 2D, but once we add the third axis, that makes it 3D axis, 3D figures. Are we clear? To watch this axis, we need something special because our eyes are not equipped with that technique, equipped not with that spectacles. So we need to wear something special in that case. So to observe it, everyone cannot afford to wear. No? Every time I cannot wear the 3D glasses to observe 3D figures. So we have a method to observe 3D figures. Let us understand. That method is known as a net of a solid shape. Net of a solid shape. What we will do, we will convert or we will represent this figure into 2. Let's understand what it means. What is a net? Net is a 2D representation of 3D shapes. 2D representation of 3D shapes. That's what makes it a net. What is the concept of net? Why we are making the concept of net in virtuality, in the originality? Because we cannot visualize solid shapes. So to visualize solid shape, we have a process called net. We have a method called net in which what we do, we convert a 3D shape into a 2D shape. Because 2D though we can see, our eyes is made to visualize 2D shape. Hence what we can do is, we can convert a 3D into 2D. Oh, that's very nice. Do you think it's a simple process? Yeah, it's a simple process. Let's observe this how. Basically, why I'm saying, because net is a flat surface pattern. So if I convert anything into flat surface, it means that will convert into a 2D shape. Let's observe. I'll give an example of a cube. For example, I'm having this cube with me. Cube is having how many faces? 6 square shape faces. 6 square shape faces, right? So what we will do, we'll cut this cube into 6. We'll cut this cube into 6 faces. Let's observe. 1, 2, 3, 4, 5, 6. Let's do. What I'll do, I'll do the slicing and I'll convert into 6 square faces. 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5, 6. This what is known as 2D representation and this is known as 3D representation. Converting 3D into 2D is called net. So this is the net of cube. Are we clear? So basically converting a 3D shape into 2D shape is known as netting. Hence this is what is a net of any shape. Basically a cube. Every 3D shape has its own net that we can visualize clearly. Last concept of the day. Let us take one more example. I'll take one more example of a cube. Last example for the day. Last example. Let's observe again my friend cube. Cube is my best friend in this chapter. It really helps me a lot in this chapter. Let's observe. Now, if I talk about a cube, top, bottom, right, left, front, back, right? This is what we'll do. Top, bottom, side, front, back. Now if I have to open this, what I'll do, I'll keep the bottom as it is, and if I open this, how I'll open, I'll keep the bottom as it is. First of all, I have to remove the top. If I have to open this, opening this is known as netting, no? If I open this 3D shape, that will convert into 2D because I can visualize, because it is in the plane figure. Now, bottom as it is, I'll open. First, what will happen? Top. So, once the top will open, either the top will come this side or that side. But along with the top, one of the sides, either the front or back will go. So, I can do that. On opening, I can write like front, and here is top. Clear? Now, if this is going this side, this will go for sure this side. This is back. Yeah? And it will be right, or if I want to say that, one of the sides will be, again just see, observe what will happen now. Observe what will happen. Bottom, top will be going with the front. This side I can take, or maybe I can take this side. I have to take this side. So it is top. Now this side, that side. Okay. Another side. What is this? This is the neck of this cube. Are we clear? This is the neck of this cube. Do remember, for neck, front and back cannot go on same side, and two same sides cannot go on same side. So if this is happening, that is the wrong concept. With this, the topic netting is over, and we have various networks for other two shapes. Till then, take care and have a wonderful day.